Thanks for being here. I know that the school isn't on yet, but it's a good. So I think my audience is progressively increasing over the week for all the talks that I've given. So let's begin with a very high level overview. So internet advertising is big today. It's a $31 billion industry. Advertisers like it because it gives them a massive audience in form of all of internet. Publishers like it because they can make money off it, right? They can monetize the traffic. By publishers, I mean blog sites, news sites, syndicated search engines, which are these niche search engines that are too small to run ad networks of their own. So they get ads from these existing ad networks for some revenue share agreement. One of the dominant payment models here is pay-per-click advertising. What this means is that an advertiser is going to pay per click to the ad network, and the publisher is going to make a 70% cut on every click that happens on their site. Because of this really strong financial motive, because they're making 70% of each click, there's the possibility of click fraud. Click spam are basically fraudulent or invalid clicks. The reason we call it click spam and not click fraud is a lot of times when you get down to investigating them, it's really hard to pin down the fraudulent intent. You can just say that these are invalid. But the end result is that the users that are delivered to the advertiser's page are not interested in the content. And so advertisers lose money, they don't get any return on investment. If you look at the motives, you can either have malicious advertisers or other parties that are trying to deplete a competitor's budget. So they'll just turn off their own ads and then let these bots go and click on every ad possible on the particular topic and then run the other competitors out of budget. And there have been isolated cases of these, but the stronger motive lies with the publisher because they make money if that happens. So here's an example. So Microsoft's ad network was attacked by this particular publisher called Red Orbit, and the way they did it is they had these spark domains that were funneling clicks that had invisible ads. So anywhere you click on the page, it's going to result into an ad click. Here's another example which we all may be familiar with in one way or the other. This snapshot shows a mobile game, sadistic game in my opinion, called Ant Smasher. The way you win the game is to squish the ants. Notice the placement of the ad very close to where the ant is appearing. So if you miss the ant by a very small margin, you end up generating an ad click. And all these are mobile games, so think about the form factor of the device and how easy it is to miss in this case. They don't even place it on the top, right? Because you are in a hurry to press it towards the bottom when the ant is actually going to go out of the state of the screen. So I've given you two examples. We're going to look at many more later in later part of the talk, but the general question of how much click spam is out there is actually very hard to answer. And the reason is you need to actually guess what the user thought when he was doing the click. So you need to guess his intent, and that's extremely hard. The second thing is different segments of traffic may actually have different amount of click spam. So think about it. Mortgage ads, each click is $7 or $8. And if you're making a 70% cut, you can imagine you're making $5, $6 of it. If you are, on the other hand, plumbing equipment, right, maybe the click may be retailing for $1 a click, 50 cents a click. In that case, a publisher makes only 70% of that. And so you can imagine that maybe mortgage ads have a higher amount of spam coming to it than plumbing equipment ad. Ad networks will give you aggregate numbers. They'll tell you, oh, Google or Microsoft has X% traffic, click fraud traffic or click spam traffic. But it doesn't tell you how much spam is going to come to your ads as an advertiser. Third, ad networks aren't transparent. This means they decide how much to bill you for each click, but they will not tell you which clicks were billed and how much were they billed for. So it's not very open. And there is good reason for this, because if suppose I laid out the rules in the open, right, that this is how I'm going to count or discount clicks, you would expect that first thing that would happen is publishers are going to try to cheat the system to make as much money as possible. Second, advertisers are going to cheat the system to pay as less money as they possibly can while getting traffic. So there's reason why they aren't transparent. And finally, there's a feeling in the community that if you want to do click fraud research, you probably need to be inside Google or Microsoft. So researchers lack real attack data. So, in terms of contributions of this work, we try to address all 4 problems. So here is the first method to independently estimate the amount of click spam as an advertiser for the set of keywords you are interested in. We take this method, apply it to 10 ad networks, search, contextual, mobile, social ad networks. We show that click spam is a problem, especially for mobile and social ad networks. And while discovering where all this bad traffic was coming from, we discover 5 classes of sophisticated attacks that are going on. And I'm going to point out in this talk why some of the heuristics that we all may think of don't work in catching them. And finally, sorry.
So you have these 4 categories: search, contextual, social, and mobile. Can you give us some sense of what part of the online ad market those different categories are? Like search is...
What's the fraction?
Yeah.
Are
the 4 of those together 90% of the online market, or is there a lot of other categories that you talked about?
So for pay-per-click advertising, this is probably the 4 segments that are there. I know that, I don't know what social is, mostly Facebook today, but I don't know what the revenue is. Mobile total is, I believe, $500 million out of the 330 billion that's there, and it's growing. So I think both mobile and social are growing sectors. Every year you see that the revenue that they get is increasing. Yeah. And so finally we release the data to researchers. So if you feel like you have some cool ideas you want to try out, the data is out there. The approach, in terms of approach, so here are the high-level points. So the first thing that we realized that it's incredibly hard to classify any single click as good or bad. In fact, I spent like a year looking at it, okay, trying to classify a single click. And so we changed the problem a little. We say we are going to try to estimate the fraction of click spam that's coming to you. What this means is we may be able to tell you that 30% of the traffic coming to your ads is bad traffic, but we may not be able to identify which 30%. And this is because we design a Bayesian estimation framework that uses only advertiser measurable quantities. So anything that an advertiser cannot measure, we try to cancel it out by relating different mixes of good and bad traffic. That's the very, very high level sort of view of what we tried to do. To go into more details, here is the main idea. So you have an ad. You have both spammers and non-spammers that are clicking on this ad. When you click on the ad, you go to this landing page. Now, when you see the landing page, some of your non-spammers are actually going to buy your product or sign up for email. We call these sort of users gold standard users. And your question now is, what is the fraction of non-spammers among all the people that are there? So suppose you could take the same ad, but you could insert a black box. Now this black box has 2 properties. First, it can get rid of all the spammers, but in the process it's going to lose some of the non-spammers. And second, if you actually make it out of the black box, your chances of becoming gold standard are the same as before. So now you can equate the ratio of non-spammers to gold standard users in the second case to the one in the first case, and you can estimate the amount of non-spammers. That is the very high-level idea of this work. So now the question is, what's the black box? So the black box consists of hurdles. Hurdles are based on this following intuition. A click spammer is, by definition, not interested in the advertiser site. He is interested in the click because it generates it causes the money transactions to happen. So he's unlikely to do additional work to get to to view the advertiser site. So you place a hurdle, which in this case requires an extra click to be able to see the advertiser's page. Now, different hurdles have different hardness. You can have a 5-second wait hurdle, a click to continue hurdle, and of course, hurdles actually affect the user experience, right? You don't want to do this extra click when you're viewing it. So you send only a fraction of your traffic through the hurdles when you're suspecting bad traffic, for example. Now, and finally, a perfect hurdle would block all spam, but in reality, you expect that some spammers are going to get through anyway, so you need to correct for false negatives. And the way we correct for false negatives is using bluff ads. So bluff ads are ads that have junk ad text, but normal keywords and targeting. And you don't expect normal users to click on them. To see why, here's an example. On the left, you have, left, right? Yeah. On the left, you have a normal ad for celebrity cruises. On the right side, you have a bluff ad, which reads massive smile literature, cream fix gutter bad keys. So just eight words picked off the dictionary. The reason these ads work is because the ad networks target the ads based on the keywords provided with the ad, not the actual content of the ad. So that's why they work. But what happens is you have this bluff ad, you pass it through the hurdle. Now you know how many spammers or curious users it's letting through, so you know the maximum false negative rate for each hurdle. And that means that our estimates on click spams are going to be lower bound estimates on click spam. So you can subtract out this traffic from the traffic that was there before, and so you have an estimate of the amount of click spam. So I presented the method at a very high level. So we sign up as advertisers for 10 ad networks, social, contextual, mobile, social ad networks, including Google, Bing, AdMob, Facebook, InMobi, and others. Yeah?
Sorry, so I'm just trying to understand the previous step. So you're presuming that the click fraud people aren't doing anything intelligent about the content of the ad themselves, right? So you said the ad network is based just on the meta tags. But one might presume that the people doing click fraud are trying to be intelligent and may actually only push through on ads that meant something, like they know they only make money on Viagra ads or something, and so unless it has the word Viagra.
That is correct. But yeah, I mean, that's a very good question. And yes, we assume that, but that's because the spammers today don't do any such intelligent choices. Based on things that we have looked at, based on the traffic that we collected when we actually showed these ads. You can catch a significant fraction of badness by doing this. So suppose you're a botnet, right? You don't have, the bluff ads don't have to be so blatantly bluff. You can have transparent ads, for example, where there is no content there. Now bots cannot see that if they're just trying to read the tags, whether there is anything there. You can have mistargeted ads. So if for example, Facebook has a lot of information about people, they can just target ads where user is unlikely to click on these particular ads. So you don't have to be so blatantly bluff about it, but the thing is today, even such blatantly bluff ads work.
I guess my question is, they work in the sense that they get some traffic, but you were using that as an approximation of the bot traffic. But how do you know that that actually is getting the majority of or all of the bot traffic and not, maybe the bots are more sophisticated? How do you know? Do you have some gold standard of?
Based on what we have seen, what we have manually investigated, we don't see bots doing that today. But you can assume that bots will probably be more sophisticated tomorrow. But then it's an arms race. So we show 240 ads using 3 keywords: celebrity, yoga, and lawnmower. Celebrity is a high popularity keyword. Yoga is a medium popularity keyword. Lawnmower is a low popularity keyword. And we use 2 types of hurdles: a click to continue and a 5-second wait hurdle. And to give you an idea, this is how the ads and the landing pages look like. On the right side, we have the ads, and on the bottom, we have the landing pages. So reasonable. They look reasonable. Though I was afraid that the screen was getting cut to some extent, but that's fine. In the end, we got 50,000 clicks, 30,000 of which were bluff ad clicks. And it cost us around $1,500 to do these experiments. But now we run into a sort of problem because we don't have ground truth to compare against. How do we know whether we are doing any good? So what we do is the next best thing. We compare against search ads on Google and Bing. And we expect that these networks have been around for long enough that their click spam detection is mature. Even if they aren't, at least we can do comparative measurements between these and the other ones. So let's see how the results look. So we tried to do a validation using search ads. And the way to read this plot is the x-axis is ad networks A and B, one of which is Google, the other one is Bing. On the y-axis, you have the complementary click spam rate, that is the amount of valid traffic. The color represents the type of the ad. Pink is celebrity, green is yoga, blue is lawnmower. The height of the bar represents what the ad networks charged us, so it is their estimate of valid traffic. The dot represents our estimate, and with the error bars. And what you can see from this plot is that for yoga and lawnmower, we're actually pretty good in terms of estimating. So our estimate and the ad network's estimate match pretty closely. For the pink celebrity ads, our estimate of valid traffic are lower than the ad network's estimate of valid traffic. And so one of us is wrong. And when we set out to manually examine the difference, we saw that this was coming from syndicated search traffic. So we created another campaign. And this time did not allow syndicated search traffic. So this involves just the big ad network and us. So there's no incentive for fraud. And when we do that, we see that our estimate actually sits right on top of their estimate of valid traffic. So we are pretty good in estimating the amount of click spam. To show you a very contrasting picture, here's mobile ad networks. So on the x-axis, we have Google Mobile, Bing Mobile, InMobi, and AdMob in no particular order. And on the y-axis, we have, again, the complementary click spam rate. And you can see two things. First, our estimates, the dots, are uniformly lower compared to the previous case. So the valid traffic fraction is lower. And second, most of the ad networks, ABC, are actually charging you for this traffic. Again, there is a discrepancy between our estimates and the ad network's estimates. And we instrumented the landing pages to see how long people were staying at the advertiser's page after they click. And we found that the 50% of the traffic in the best of the ad networks wasn't staying for even 1 second before shutting the page. Yeah.
So you're basically saying is you're spending your money on firing advertising levels?
Pretty much. Pretty much. And then to complete the picture, here we have the contextual and social ad networks. We have Google Contextual, Bing Contextual, and Facebook. For ad network B, they did not approve 2 of our ads, so we don't have an estimate. Because we aren't selling anything real, right? I mean, you expect the real advertisers' ads to be approved. For green ad on A and blue ad on C, we did not get statistically significant number of clicks to be able to give an estimate. But what you can see from the picture is the situation isn't as bad as mobile, but it's not as good as search either. So there's room for improvement here. And for the ad network B, there's some serious flaw in their accounting algorithm because they keep charging us 30% more clicks, 40% more clicks than actually hit our server as an advertiser. So there's something wrong that they need to fix.
Did you contact them about
Mm-hmm. And no replies, but yeah. But we contacted all the ad networks with the statistics that they, so yeah.
Is this just Facebook, or is this Facebook and several other ones?
The social ad network is just Facebook.
So what is the incentive for someone to click on your ad on Facebook? 'Cause
Okay.
The only person who's making money there is Facebook.
Yeah, so we looked into it a little bit. No, we looked into it a little bit, and this is how it seems like it. So in Facebook, right, if you are, say, Boost or Bonvita or any of these agencies, you want to create a campaign. You go to these ad agencies and you tell them, okay, I want to do a Facebook campaign for advertising, right? So the ad agency actually handles the clicks, and they have an incentive. We know of at least a few shady ad agencies that have 500 fake user profiles of their own on Facebook. So they create the campaign, then they use the fake profiles to generate clicks on it, for one example.
You think that the person generating the Facebook is the ad agency?
It's possible. I mean, I wouldn't want to comment on what exactly is happening, but that is one of the things. The others may be bots that are crawling and are not careful about which are ad links and which are not. There are Facebook crawling bots. So, So those are possibilities, but I'm only speculating here.
Oh, I was just wondering, did you filter out all the bot traffic to all of your servers?
This is a comparison between the two. Yeah. Between the two traffic. Yeah.
So in search, most of the advertisers have the practice of, once they determine if they think that a click was fraudulent, they'll refund you.
Mm-hmm.
Is there an equivalent thing here for contextual advertising? Is that included in this?
We got only one refund from one ad network for $2, and I've loaned $1,500 on it. So yeah.
Big part of it.
Yes. Yeah. Go on.
Were your analytics done using JavaScript, or were they done on the server side?
So the pages were instrumented with JavaScript, but we were also tracking the pages without no script tags, so we excluded those guys. So you see all this bad traffic, right? The next obvious question to ask is, where is this traffic coming from? So one cool idea would be to analyze Bluff ad clicks. For once, you have ground truth. And typically, typically when you do click fraud analysis, you look at either clicks or users. We decided to look at publishers because they are the ones who have strong motive here. And we started doing a manual investigation, but we run into the problem of scale. We saw 3,000 plus publishers, 30,000 clicks. And if you saw the first slide, I'm the only student on the paper. So it's up to me to investigate. But luckily for me, when I load some of these sites up into the browser, I see that they're exactly identical. So the idea seems to be that these sites are creating Sybil nodes of themselves because to beat any ad network thresholds that may internally be there. So the obvious thing to do at this point of time is to do some sort of clustering. We create a feature vector using their whois information, their IP address, subnet, HTTP parameters that they come in through, where the URI path. And then we cluster based on cosine similarity. When we do that, this beautiful plot emerges, which is full of cliques. Here, a node is a publisher site. A link between them shows that the cosine similarity is greater than a particular value. And the really dark red ones are the ones where the cosine similarity is actually 1. So they're hosted on the same IP address, same subnet, same whois provider, registered on the same date, the domain expires on the same date. The path is similar, so they're just different looking websites, but yeah, all shoving clicks to the ad pages. So if you look at some of them, this is how they look. And when you load them up, you can be confident that they have the same sort of owner. So basically, publishers are creating Sybil nodes to beat any ad network thresholds that may be there. But what this does for me is it reduces the problem of scale. Instead of looking at 3,000 or plus publishers, now I'm looking at 80 or so clusters. And the rest of the talk is going to be about how we found some of these guys and how they were funneling click fraud. So the first case study I'd like to present is malware-driven click fraud. And the way we found it worked was, here's a user, Jane. She has a malware-infected computer. So Jane searches for books in her browser. In the background, there is a call made to the bot master, identifying Jane's bot ID, the search engine that she did the query on, the query term. And then in response, the bot master generates a list of publishers. Now this publisher list is back at Jane's browser. And now when Jane generates the first search click, right, not the first ad click, in the background, a call is made to the first publisher site. And after 8 or 10 redirects, it ends up being, it ends up on an ad. So notice that all this is background traffic. So unless you're taking Wireshark traces, you wouldn't see any of this happening. To go into more details, the particular malware family responsible here was TDL4. And the way we validated it is we found that these particular publishers figured in their malware reports, connection reports. We found the malware variant. We installed it in a virtual machine, ran it, and that's how we know that it did this. This particular malware is sophisticated. It can intercept and redirect all browser requests that are there. So any browser-specific filtering doesn't work. Then second, we saw that it did only 1 click per IP address per day. So the bot master keeps track of what IP address the networks, what IP address you see from the outside, and it won't do another click till 24 hours have passed on the same IP address. However, if you connect to a different sort of network from the same device, it will wake up, do another click, and go back to sleep. So it's incredibly low threshold attacks.
So it's the actual public address or the IP address on the machine?
It's the public address that the bot master sees on the other side. Yeah. And finally, this bot mimics real user behavior. So if ad networks today are doing timing analysis, like Jane doesn't search except if it's her lunchtime, or how much time it takes to click, those kind of things, since they're modeled on actual clicks, you won't be able to catch this sort of attack. The second attack that I would like to touch on is arbitrage. This was coming from these incredibly polished looking sites. Here's one example. They pose as question and answer forums. And we were receiving Bluff ad clicks on one network from these guys. And they didn't figure in any malware report. So we know that the traffic is actually human generated, right? Some sort of. Next, these are not popular sites. So you don't expect them to be getting a lot of traffic. Their Alexa rankings is in hundreds of thousands. So where are they getting traffic from? Finally, when you try to load them up, you actually don't even see ads anywhere on their page. So this was really puzzling for me. But when we started investigating them a little more, we realized that all the content is actually copied from people's Facebook pages and other places. So that gave us some hope that, okay, they are actually phony sites. Furthermore, when we tried to post our own question on it, the question would simply disappear. So they had a front end, but they didn't have a back end sort of database to keep track of the questions. And what we realized is they were acting as advertiser on another ad network. They were showing 4,500 plus ads when we investigated them. And when you come in through this particular ad, right, all you see on the pages are ads. There are no questions, no answers, just ads. And to give you an idea, on my Mac, all you can see when you load up the screen is the box that I've encircled. That's the ratio. So all you see on the page are just ad links. So basically, they're confusing users into clicking. And the way they work is, so this particular ad that they paid for is on a contextual ad networks. Contextual ads are cheaper than search ads. And they're bidding on work from home now hiring, that particular phrase. Here they're bidding on airport jobs, which are much more expensive ads, and these are search ads. So they're paying pennies to get the traffic to their site. They're making dollars for the clicks that happen on their site, and they pocket the difference. That's their revenue model.
Why are people clicking?
Because all they get on the site is just ads. So first, you're trying to attract people who are already into clicking, because they've clicked an ad to get here, right? And then second, all you see on the page are just ads.
Well, let's suppose they're making $5 on the airplane ad, and it's a penny for one of these. For this to make sense, it still needs to be the case that the likelihood is, I don't know, 1 in 5,000 is better than 1 in 5,000 that someone's going to click.
Yeah, but the thing is, when people come in through this click, they're already likely to be clicking on ads.
So there are these set of people who know you don't want, because in some sense the intent of the user for these people isn't relevant, because they are mindless, click-happy people.
Sort of. I mean, or people who are just confused into clicking, right? I'm sure my grandmother would be, for example, if she's browsing.
Right, but so in some sense those are not useful clicks, because they're not going to buy, they're just clicking.
I'm not sure I buy that. I think they click on an ad, and then what they're doing is they're lost and confused, and they've already committed to finding this work from home hiring thing that they clicked on, and now they're saying, where is it on this page? And then they just click on something else, they're committed to the transaction, at least enough to go first through a hurdle, a 5-second hurdle, right? I have to commit to that. And now they're just committed one more link. Oh, I'll just get one more link and we'll get where I'm trying to go.
Now, what prevents them from being much more fraudulent and making those airport links linked to the airport jobs, but having the title be, back or work from home?
Nothing actually, nothing.
They don't do that.
No, they don't do that. At least not the ones that we saw.
So there must be some pressure from auditing that.
Yeah.
Those ads are not in a separate time frame.
No, these ads are actually not. They're what is called as naked ads. And I don't understand the business model behind it. I actually asked people at Google, but they said that they go only to premium publishers. And it's the same answer you'd get from Microsoft as well. So, yeah. The third case study I'd like to touch on is click fraud using park domains. Park domains are these sites that have been registered but do not actually host any real content. Park domains are actually legal, but doing fraud using park domain is not. So here's how it works. So you have this particular user, Jane. She wants to go to ICICIbank.com. Now this is the Bank of America of India. Think of it that way. So instead of typing ICICIbank.com, she ends up typing ICIC Bank. ICICbank.com happens to be a park domain. This park domain is going to pull ads from a syndicated search engine for the term ICIC Bank. Because it's pulling ads for ICIC Bank, it's likely to get an ad for ICICI Bank and auto-generate the click on the first ad URL that it gets. Now, the end result of this is that Jane ends up on ICICI Bank, which is where she wanted to go. But ICICI Bank has to pay for a click that she didn't have to because the user was going there in the first place. So we discovered about 41 of 400 park domains hosted on a single IP address that were doing this. These are all misspellings of common names. So ICICbank.com, NSDI.com. And the auto redirect actually depends on Jane's location. So if she's located in Argentina, Brazil, Italy, India, you see them auto redirecting. If you go to these sites from US IP addresses, you will not see any redirection. And we speculate that this is because one, these countries may not have laws that may prevent it, and two, because the teams that do investigations probably sit in the US. And this particular IP address actually hosts 500,000 such domains. If 50% of them are, 10% are auto redirecting, you're looking at 50,000 of them doing this. And again, the sneaky part of the attack is the user mistypes something in a URL, and now the advertiser must pay for it. And because the user behavior, Jane's behavior when she gets to ICICI Bank is that of a normal customer, right? Using conversions naively to detect sort of click spam or click fraud doesn't work in this, at least in this particular case. Here's another example. So this is click spam, not click fraud. You can't prove the intent. So www.noblenet.org is the site for North of Boston Library Exchange. Now, it's acceptable in a lot of cases to omit www in front of a website name. What happens when you do that? Well, you end up on this park domain. And you can see that the color schemes are very similar. And if you read the content, which I don't think you can, is digital library online, library catalog, library search. That's what is there. If you end up clicking on one of these, you end up on this page, which reads library books. That's an ad, but it says target.com free shipping. So what they're trying to do is, again, confuse users into clicking. And the reason this is okay is because the domain registrar is something called Network Solutions. And they have a policy that if you don't have a certain part of your, when they sell you the domain, if you don't use some part of subdomain, they're going to be free to park it. And they're parking it with content similar to your actual site to confuse users into clicking. So these are policy issues that needs fixing. And finally, I'm going to touch very briefly on mobile click spam. So there was this one Indian mobile ad network. It supplies WAP ads to a group of WAP porn sites. And what the porns, so WAP phones are these clunky phones, the ones without a fully featured browser. And what these guys were doing, they were making the ad links, they were interleaving ad links and porn links and making them indistinguishable. So anyone who's serially going through through the porn videos ends up clicking on the ads. The other set that we identified were these games like Ant Smasher that I showed before and Milk the Cow and 50 others that are placing ads very close to where the user is supposed to be clicking it. Yeah. So let's see how the picture looks. So those are the guys that we identified were doing malware-driven spam. These are the arbitrage cluster. And you can see that the arbitrage sites actually look very, very different. But when you go into them, you sort of start noticing a patterns about the questions and stuff. These are the park domains that were sending us traffic. And those are the porn sites that I don't have snapshots for. And that was just 26% of the traffic that we got on our Bluff ads. So in the end, click spam remains a problem, especially for mobile and social ad networks. We presented one way of estimating click spam independently as an advertiser for the specific keywords that he may be interested in. We discovered sophisticated attacks. There are Sybil sites that publishers use. Malware mimics real user behavior. You have social engineering attacks where users are tricked into clicking. And finally, the data set is actually available for both the Bluff ads and the non-Bluff ads and all the telemetry data, so that if you feel you can do something funky with it, then go ahead. So that's it. Yeah?
What was the ratio of Bluff ads to normal ads in terms of
Number of clicks?
If you had them up for the same amount of time, how many clicks did they each get? How many more, what percentage was the ratio between them?
It actually depends on the ad network. So for some ad networks, you got, for example, more CTR on the Bluff ads than the normal ads. It was that bad, yeah. So I wouldn't be able to tell you off the top of my head, but what I'm saying is that it differs based on the ad network and the keywords also.
Remember Google's, you assume Google is really good at filtering these things out?
Mm-hmm.
Remember what ratio was for Google?
I can't say off the top of my head, but yeah, for Google, I could say that it was getting a lot more normal clicks than Bluff clicks. Okay.
So you talked very qualitatively about the relative costs of these different ads and so forth. I'm wondering, have you made any attempt to look at that more deeply, either in terms of how these different strategies change the incremental cost of advertising, or the normalized cost of advertising for the people who are trying to sell their products? Or alternatively, how much money these different kinds of approaches make? Right? Which are the ones that are, if you're a bad guy, which of these do you do?
So I haven't looked into it. I want to, but a lot of times the problem is, so for example, the malware case, right? You have the ad click. You can see one hop away as an ad network, right? You cannot follow the trail beyond because you don't even get visibility into that traffic. Do you see what I'm saying? There are 10 levels of syndications that are happening there. So it would be awesome to do this characterization. The problem is, in a lot of cases, you can't. In some cases, in some cases, the fraud was running to about hundreds of thousands of dollars per month, because we got confirmation for some of these attacks. But for others, it's incredibly hard to actually trace down how the money is trickling through. Though I would love to do it, because then if you know where the money is flowing, you can find the choke point and you can shut it off. But
so the Bluff ads, or the honeypot ad, so to speak, seems like a very useful mechanism for understanding who's out there is bad.
yeah.
Is your sense in talking with the main ad networks that they do not use that? Or
They don't use it today, but I think all of them have pipelines of doing some sort of transparent ads or things like that, where at least the blatant bot traffic can be caught.
And do you have a sense from them, sort of, like with credit cards and credit card fraud, the credit card networks, they know that there's going to be some level of fraud, and as long as there's sort of their estimate that it's below this threshold, then it's fine. Is there a similar sense from the ad networks as well?
So at least I talked to both the major guys, and they said something like, "Oh, if we suspect they're fraud, we're going to ban these guys pretty freely in terms of catching them." So I think they're concerned about quality just because it's competition.
Sure, but they know that they can't be perfect, and nobody can be perfect in
Sure.
this space. So do they have a target in mind in terms of, well, if we could get fraud down below some percentage, then we feel like we're going to be better than everybody that's out there, and that's what we can tolerate?
I wouldn't know about that. Yeah, I haven't talked to them at all. Someone there who wanted to question.
All right, any more questions?
Yeah.
So, I have a quantitative question which has to do with the exploiting the behavioral intent of the user.
Mm-hmm.
So let me share a personal example. When I'm trying to install some new piece of software and it doesn't work on my computer, I go into Google and I say problem, this version and that version, and then all these weird pages that come up
Yeah.
appear to provide the answer.
Mm-hmm. Sorry?
There are these pages that come up which appear to provide
Yeah.
the answer to that question.
But don't.
But they don't, right? Lots of them. In fact, Google lets through like tons of these sorts of things. It feels like it's a very systematic effort at exploiting the need for tech support and turning it into something else.
Yeah.
Is this something systematic that you're running into, or
Sorry?
are you running into this systematically, or?
Where users are, I mean, there's a whole cluster of people who are doing arbitrage, right? They're using similar templates, posing questions in a similar manner. So I'm guessing that it is pretty systematic they all have the same domain registration date. So, I mean, they are going after people in a systematic fashion. As regards to so that answers the question whether there is a systematic effort to exploit users. Whether there's systematic effort to exploit users for tech support, I don't know, because I didn't run across any tech support sites that were doing this. Though there was one arbitrage site called Service Mountain, which was sort of for tech support.